dear students, good morning. Previously we discussed about types of redox reactions. So in that last and final we discussed about disproportionation reaction. In that disproportionation reaction, I told you very clearly, one atom will undergo both oxidation and reduction. So what is oxidation and what is reduction? We know already. One example I was given, and this is the second example. So here chlorine, if you see, chlorine oxidation state is 0 here. Okay, how that is changing here? Chlorine here -1, right? Here NaOCl means Na plus and OCl minus. OCl minus. In this, what is the chlorine oxidation state? In OCl minus, the chlorine oxidation state I am taking X. Oxygen is more electronegative, so we will take -2 is equal to -1. Then X equal to +1 here. So what you observe, chlorine oxidation state changed from 0 to -1 is the one case, and chlorine oxidation state changed from 0 to +1. 0 to +1 we have. So 0 to -1 means oxidation state what happened? Reduced. So this is reduction. What this is? Reduction. Oxidation state changed from 0 to +1. Here chlorine oxidation state understood. We have to split it as Na plus and OCl minus. So OCl minus means here OCl minus is an anion actually. That's why we took -1 here charge, and X plus of -2. Oxygen is -2 here. So X is +1. So 0 converted to +1 is oxidation. So chlorine itself undergone two changes. One is Cl2 to Cl minus is the one change, and Cl2 to Cl plus actually. Okay, OCl minus. In that, what is the chlorine oxidation state? +1. So in this way, excuse me, this is about disproportionation reaction. Next we have to discuss opposite to the disproportionation reaction, which we call as comproportionation. Comproportionation reaction we have to discuss. Very simple, exactly reverse reaction. Okay, one undergone both oxidation and reduction, means one converted into two ways. Now two converts into one, means two types of ions or atoms which are belongs to same element will give one kind. So how, sir, you are saying? See, I'll give you one example. See, Ag plus 2 and Ag converted to Ag plus 2Ag plus. It's some AgCl to something. Sir, is it called comproportionation? Means yes, it is comproportionation. Ag2 plus here plus 2. Plus 2 converted to +1. Plus 2 converted to +1. Ag2 plus, how, sir, you are saying? Something AgCl2 converted to 2AgCl with silver. Here silver oxidation state is what? 0. Ag plus 2 here, Ag 0 here, Ag plus means here silver is +1. So what you observed, why Ag2 plus I consider understood, like AgCl2 like that. When react with Ag, it both converts to 2 moles of AgCl like this. Understood? But only I am writing this Ag, silver only I am writing. I am just neglecting this Cl minus. Okay? So in this way you can write otherwise. Here silver is +2, here silver is 0, because the elemental state 0 I told or not. So here 0, here +2, and +2 converted to +1 is reduction, and 0 converted to +1 is increase in oxidation state, that is oxidation. So silver is changing from 0 to +1 here. In this way you can say this is what we call comproportionation reaction. What is called? Comproportionation reaction actually. Understood clearly? So here what is the conversion you observed? Ag2 plus 2 plus converted to Ag plus. This is one change, and Ag converted to Ag plus, another change. So it's combinedly you can write like this: Ag plus 2 plus Ag gives rise to 2Ag plus. Ag 2 plus 2Ag plus is reduction, because oxidation state reduced from plus 2 to plus 1. Here oxidation state changed from 0 to plus 1. That means increase in oxidation state. So that is oxidation. So 2 converted to 1. 2 converted to 1, comproportionation. 1 converted to 2, disproportionation reaction. This is the main difference between disproportionation and comproportionation. This is a very important thing you must remember. And one more important thing, you have no need to by heart any reactions. They will give options and you have to check which is disproportionation, which is comproportionation, which is a displacement reaction, which is a decomposition reaction, which is a combination reaction. These all things you must know. Please have a note, and notes is very important. As I said, you must write all these things. Okay, I'll revise this. Next we will enter into few more applications of this particular concept. Okay, concept means like who undergo disproportionation, who cannot undergo disproportionation. Like that also they will ask questions. Okay, just applications. Let's see applications of this. Okay, next applications of disproportionation reaction. So they'll ask you few important things like who will undergo disproportionation, who cannot undergo disproportionation, like that. Suppose here I'll give some options like F2. Okay, next is the Cl2, next Br2, third option, next fourth one is I2. So among these, who can involve in, who can not involve in, who can involve in all these three. Who cannot undergo disproportionation means F2. Which question is, which cannot undergo disproportionation reaction? This is the question. Which of the following cannot undergo disproportionation reaction means F2. Sir, why sir F2? I will explain now. Disproportionation means one should undergo oxidation, the same should undergo reduction. Means that particular atom must undergo oxidation and reduction. That means that particular atom should increase its oxidation state, should decrease in oxidation state. That means that particular atom should lose electron, at the same time should gain electron. Both should happen. But fluorine, if you see, fluorine cannot lose electron. It always, F can convert it to F minus only. So here oxidation state, what happened? Decrease only possible. F converted to F plus like this. Then 0 converted to plus 1, which is called what we call oxidation state. Oxidation state increase. So this is oxidation, which never happened. This never happened. Fluorine can never lose electron. Why sir? As I said, it's a most electronegative atom. Its electronegative value is 4. It cannot lose electron. So fluorine can it undergo oxidation? Never. So what I said, that particular atom should, one particular atom should undergo both oxidation and reduction. In case of fluorine, that is not happening. So here in this case, fluorine cannot undergo oxidation. That's why disproportionation is not possible. At the same time, some molecules like SO4 minus 2. Sir, will it undergo disproportionation? Means no. Why sir? How we are saying no? Means sulfur which group? 6th. So sulfur can have maximum oxidation state plus 6. In this SO4 2 minus, if you calculate x plus 4 into minus 2 is equal to minus 2, x equal to plus 6. So already having maximum oxidation state. Already having maximum oxidation state. So can it lose further electrons? No way. So if it lose electron, it have to increase its oxidation state. Already in SO4 2 minus, it is having maximum oxidation state. So can it undergo oxidation further? No. That's why SO4 2 minus is SO4 2 minus cannot undergo disproportionation reaction. Reason understood, everyone? SO4 2 minus, I repeat, it cannot undergo disproportionation because it is having maximum oxidation state. So okay, here we had one clarity. What is that clarity? Atom which has a maximum oxidation state that cannot undergo oxidation further. Yes, correct. Like NO3 minus, I'll say this cannot undergo disproportionation because nitrogen, if you see, nitrogen x plus 3 into minus 2 is equal to minus 1, x equal to plus 5, which is called maximum oxidation state. Sir, how you are deciding, sir, this is maximum oxidation state? Because nitrogen is 50A group. So its maximum oxidation state can be plus 5. So during oxidation state should increase from plus 5 to something else like plus 6 or plus 7 like that. It's not possible because any atom will have maximum oxidation state which is equal to its group number. Which is equal to what? Group number. Understanding, sir? So like that they'll ask you. So a few more example I will give you like this PO4 minus 3. So this cannot undergo disproportionation because phosphorus have maximum oxidation state. You can check once. X plus 4 into minus 2 is equal to minus 3 and x equal to plus 5. Phosphorus also fifth group. Like that. Cl2O7. Otherwise, okay, enough. Written already. So I'll take this example. Cl2O7. Will it undergo Cl2O7? Yeah. Will it undergo disproportionation? Means I'll say no. Why? Because chlorine is a 2x plus 7 into minus 2 is equal to 0. Then 2x equal to plus 14 and x equal to plus 7. Chlorine, as I said, it is a 7th halogens. It is having maximum oxidation state. So further oxidation and reduction. Further oxidation not possible. It can undergo reduction. It can decrease its oxidation state. Do you know what is the minimum oxidation state and maximum oxidation state for halogens? You know, general oxidation state I said. Do you remember or not? That is group number minus 8. So suppose I want general oxidation state of Mr. Chlorine. I'll take 7 minus 8. This is minus 1. So for chlorine, minus 1 is the minimum oxidation state. Minus 1 is the minimum oxidation state. Understood clearly? Yeah. Maximum oxidation state is a group number. Got it, sir, everyone? Like that. For sulfur, minimum oxidation state is minus 2. Same way, H2S cannot undergo disproportionation. Disproportionation not possible. Cannot undergo disproportionation. Why? Sulfur is minus 2. Minus 2 is the minimum oxidation state. How we said? Group number minus 8 is the minimum oxidation state. Sulfur which group? 6th. 6 minus 8? Minus 2. So already it's minus 2. Least oxidation state already there. So can it reduce its oxidation state? That means it cannot undergo reduction. It cannot undergo reduction. Remember this one. H2S cannot undergo reduction. That's why disproportionation not possible. Why cannot undergo reduction, sir? Because its oxidation state is already minimum. Here, sulfur oxidation state is already maximum. It cannot undergo oxidation. Maximum oxidation not possible. Minimum reduction not possible. Already minimum. how it can reduce. Getting what I am saying? It's very clear point here. H2S cannot undergo disproportionation because sulfur has minimum oxidation state. For nitrogen, like fifth year group, what is the minimum oxidation state? Tell me. Group number -8 is the minimum oxidation state. Minimum oxidation state. So for nitrogen, what is the minimum oxidation state? It's 5 minus 8 minus 3. Getting what I am saying? Like that HCl -1. There is the least oxidation state that cannot undergo reduction. Already least is there. So cannot undergo reduction. Cannot undergo reduction means cannot reduce its oxidation state. Got it what I am saying? Like that. Any example like pH3 cannot undergo disproportionation. Why? pH3 cannot undergo disproportionation, sir. Means phosphorus already having minimum oxidation state. So I am concluding now, which has a minimum oxidation state and which has a maximum oxidation state cannot undergo disproportionation reaction. Got it everyone? So I repeat here final conclusion. You please make a note and write down in a box. So the atom in a molecule which has a minimum oxidation state or else which has a maximum oxidation state cannot undergo disproportionation. Clear? So the examples, those examples which I was given here 1, 2, 3, 4 and here 5, 6 and 7 fluorine, these all cannot undergo disproportionation. Got it sir everyone? And last and final, I will give you one example. I am writing here Cl2O. Can it undergo disproportionation? Yes. Why? See, chlorine oxidation state 2x plus of -2 is equal to 0. That means x equal to plus 1. X equal to plus 1. So chlorine, it's not minimum oxidation state, it's not maximum oxidation state. Yeah, it can undergo disproportionation. Got it what I said? It's not, see in Cl2O, chlorine oxidation state is plus 1. What is the chlorine minimum oxidation state? -1. What is chlorine maximum oxidation state? +7. But here in Cl2O, chlorine has +1. So it's not minimum, it's not maximum. In between minimum and maximum, if oxidation state is present for a particular atom in a molecule, then disproportionation possible. Hope you understood. Okay, still if you have any doubt, please ask me and have a screenshot and write down all these examples, star examples here 1, 2 and 3, 4, 5, 6, 7 and here Cl2O I given which can undergo disproportionation reaction, please. Okay, so hope you understood about these applications which are very, very important for us. Okay, so next we have most important topic in this chapter, that is balancing of redox reaction. Balancing of redox reaction. Very, very important. So our next topic is balancing of redox reactions. First, I use one method, balancing of redox reaction by ion electron method. Ion electron method. This method I use to balance a redox reaction. So hope everyone understood what are the types of redox reactions. So those redox reactions, how to balance, let's see, by ion electron method. To understand this balancing of redox reaction, we should know few rules one by one. First, identify both oxidation part and reduction part. This we have to identify first. identify both oxidation part and reduction part, which we use oxidation half actually. So reactants to products we will check. We will identify in which oxidation happened, in which change reduction happened, we have to identify. Next, after identification, our second point is separate both oxidation half, that means oxidation part, and reduction part or reduction half. This we have to do, second step. I'll take example, I'll do here so that you will understand. Don't worry. Okay, first I'll give you some rules what to do. Identify both oxidation half and reduction half, and separate both oxidation half and reduction half. Second thing. Afterwards, now balance. Okay, what we have to do? Balance first number of atoms. Balance number of atoms other than oxygen and hydrogen. This we have to do. So we will separate, means two halves we will write. Oxidation half, like two columns. Okay. In first column, suppose oxidation half I am taking, and in second column I will take reduction half. In that I will balance number of atoms other than oxygen and hydrogen. Got it what I am saying? I will do that by placing or by putting or by placing some suitable number. By placing suitable number. Suppose here Cr2O7, okay, minus 2 and converted to CrO3. So here two chromiums are there. Here one chromium is there. I will put 2 there like that. Okay, I will give example. Don't worry. So like that we will balance. See, oxygen I won't balance first. I will balance chromium here. Other than oxygen, what do you have here? Chromium. In reactant side 2 chromium is there. In product side 1 chromium is there. So I will put suitable number like 2. Suitable number is 2 only now because here 2 chromiums are there. Like that. So our third point is balance number of atoms other than oxygen and hydrogen by placing suitable number. Understood? Okay, this is the third point. Next, fourth one is balancing of balancing of oxygen. Balancing of what? Oxygen. Okay, so what I will do for balancing of oxygen? I will add number of water molecules. I will add what, sir? Number of water molecules where I have number of oxygens are less. Suppose here in reactants I have 7 oxygens, in product side I have 3 oxygens, so 4 remain, 4 required in product side to balance oxygens. So I will add 4 oxygens, means 4 water molecules, sorry. So this is very, very important. Balancing of oxygen, I repeat. Balancing of oxygen, how I will do, I will write here first. Okay. Oxygen can be balanced, okay, by placing number of water molecules. By placing number of water molecules. How many number of water molecules I have to place? How many number of oxygens are less? Okay, I repeat. Oxygen can be balanced by placing number of water molecules where the number of oxygen atoms are less. This I have to do. What I have to do? I have to add water molecules. Add water molecules where the number of oxygen atoms are less. That I will do. Suppose SO3 minus 2 is converted to SO4 minus 2. Here 3 oxygens are there. Here 4 oxygens are there. 1 oxygen is less in this side. So one water molecule I'll add like this. In this way, I'll balance oxygen. How to balance oxygen? Tell me. Add number of water molecules in which side that particular oxygen atoms are less. Those particular oxygen atoms are less. There you have to add what? Number of oxygen atoms. Sorry. You have to add number of water molecules. Sorry. Hope you understood how to balance oxygen. Add water molecules, okay, in the particular direction, or direction means in which side the number of oxygens are less. One oxygen is less, one water molecule. Two oxygens are less, two water molecules. Three oxygens are less, three water molecules. Giri number of oxygens are less, Giri number of water molecules. Where you have to add? Where the number of oxygens are less. So what I did first, identify both oxidation part and reduction part and separate them and balance number of atoms other than oxygen and hydrogen by placing suitable number. Okay. So I was given 2 chromiums in reactant side, 1 chromium in product side. Put 2. Like that I do. 4 phosphorus like this. P4 is converted to PH3. How to balance phosphorus? By putting 4 here. Because before putting this is one conversion. This is a 0 converted to phosphorus minus 3. This is a reduction. How to balance first phosphorus? By putting suitable number like 4. Afterwards I will balance oxygen. If there, if not there, how to balance? No need. Okay. If there, how to balance oxygen? By placing water molecules. How many water molecules we have to add? How many number of oxygens are less in either reactant side or product side? Please have a note these 4 points. Next, I'll give you the most important rule, that is balancing of hydrogen. That depends on medium actually. So I'll write that. Have a screenshot and write down. Okay. So next is balancing of hydrogen. Balancing of hydrogen, that depends on medium, as I said in previous. Next, 5th point is balancing of hydrogen. What I am doing, understanding? We are balancing redox reaction. To understand that we have to follow some rules. So those rules how to, okay, how we have to apply, we are learning. So balancing of hydrogen, one is in acidic medium and basic medium. So balancing of hydrogen, that depends on medium. Then how will come to know, sir, medium, either acidic medium or basic medium? Very simple. On arrow, if they said H plus, they represent H plus, that is what? Acidic medium. On arrow, if they mention OH minus, that balancing we have to do in basic medium. That's it. So how to balance hydrogen in acidic medium means very simple. See, balancing of hydrogen takes place. Hydrogen balancing should be otherwise like this. Hydrogen can be balanced, I write. Hydrogen atoms, we have to balance, okay, by placing number of H plus ions. Number of H plus ions, okay, what we will place? We will place number of H plus ions in particular which side the number of hydrogens are less. This you have to do. Very, very important. Please remember what I written. In acidic medium, H plus ions we can balance by adding number of H plus ions in which direction that number of hydrogens are less. Very clear. Got it, everyone? So in acidic medium, H plus ions we will add, that's it. Where we will add H plus ions? Where the number of hydrogens are less. This we have to follow. This is number of how to balance hydrogens by adding H plus ions. I told you here. So I repeat, balancing of hydrogen in acidic medium, how we will do, I said. We will balance hydrogens by adding number of H plus ions in which side? Which side means what is the meaning? In which side means in reactant side or product side. In which side the number of hydrogens are less. This we have to follow. This is balancing of hydrogen in acidic medium. Now balancing of hydrogen in basic medium. What medium? Basic medium. In basic medium, how to balance hydrogen means balancing of hydrogens. How means by, listen carefully, it somewhat confusion, but I'll clarify, okay, in a smooth manner. Okay, so balancing of hydrogen, what is this? Balancing of hydrogen in what medium? In basic medium. In basic medium by adding number of OH minus ions. By, see, balancing of hydrogen in basic medium, balancing of hydrogen in basic medium we will do by adding number of OH minus ions. How we will balance? Balancing of, I'll write clearly. Balancing of hydrogen in basic medium. In basic medium. How? By adding number of OH minus ions. Where we will add? By adding number of OH minus ions in which side? In which side number of hydrogens are more? Don't get confused. So we will balance hydrogen in basic medium by adding number of OH minus ions in which direction number of hydrogens are more, and we also have to add number of water molecules in opposite side. But how many? Add same number of water molecules in opposite side. These all points you please remember. Okay, so first what I said, identify oxidation half and reduction half, separate, balance atoms other than oxygen and hydrogen I said, and afterwards how to balance oxygen atoms I said. Okay, how to balance oxygen atoms by placing number of water molecules in which side the number of oxygens are less. But balancing of hydrogen, that depends on medium. One is in acidic medium and one is in basic medium. Acidic medium is very simple. How we will balance hydrogen? By adding number of H plus ions. Simple, directly, single shot. Where the number of hydrogens are less, there we will add those many number of H plus ions. But in basic medium, how to balance hydrogens means by adding OH minus ions. By adding OH minus ions. But what? In which direction the number of hydrogens are more? And one more thing you have to do. Not only that, in opposite direction means OH minus ions. Suppose you add it in reactant side, then we will add water molecules. Same number of water molecules in opposite side. One more we have. In example, I will tell you that balancing of charge. How to balance charge we will understand, and we will discuss some examples in our next class. But I can continue now, but you also have to clear about all these rules so that examples you can understand clearly. So make sure about all these rules and disproportion and comproportionation. Based on that only you will have assignment. Again, types of redox reactions, and as well as these some points like this. Okay, but based on these points we will have some examples to balance redox reactions in our next class.